Alright, in this video we are going to be simplifying radical expressions. So in the past few sections we have simplified radicals individually. Now we're going to have some expressions that have maybe more than one radical in it. We're going to be adding, subtracting, and multiplying them, and we're going to see how this works. So this first section right here, or this first example, I'm sorry, has three different radicals that we're adding and subtracting. Notice here that the square root of 7, the square root of 7, and the square root of 7, all of my radicals have that. So when we're adding and subtracting radicals, we do have to have like terms. So like terms in radical land means that they have the same number under the radical, that number called the radicand, or the base number that's underneath here. That number has to be the same, as well as the root has to be the same. So since all of these are square roots and all of them have 7 under the radical, these are like terms and we can add them or subtract them. So very similar to adding and subtracting like polynomials, where we have x or x squared. They have to be like terms in order to add them, and we add them the same way. We just take the coefficients out front and add or subtract those numbers. So first thing is to make sure that they all are like terms, and since these all are, we can go ahead and add the coefficients. So I would just do 6 plus 5, which is 11, and then 11 minus 3, which is equal to 8. So this would just be equal to 8 square roots of 7. So just like when we're doing polynomials, and we add or subtract, like if I were to add 2x squared plus 5x squared equals 7x squared, we don't change the radical, just like we don't change the variables or the exponents here. So we just add the numbers out front. Okay, so let's try another one. All right, in this one, we have a radical with a 50 underneath. It is a square root, and then we have a radical with 32. So they're both square roots, but that number under the radical is different, so we can't simplify this yet. So what we're going to do is we're going to simplify each one individually and then see if we can combine them afterwards. So I'm going to kind of ignore the one side. I'm just going to look at the square root of 50. I'm going to break this down just like we have been. So 2 times 25 is 50. And then 25 is 5 times 5. So because this is a square root, I need two numbers the same in order to bring one out. So I've got those two 5s. And I'm going to bring a 5 out. But notice there's already a 2 out front. So because there's already a 2 out here, I'm going to multiply this 5 that I'm bringing out by that 2. This 2 is going to stay underneath because it doesn't have a partner or a copy. So on the outside, I've got 10. On the inside, I've got 2. So that's just the first piece, right? Now I'm going to look at the second piece. I'm going to break down 32. 32 is 2 times 16. 16 is 4 times 4. And each of these are 2 times 2. Again, it's a square root, so I'm looking for pairs. So I have a pair of 2's here and a pair of 2's here. So I can bring out 2 times 2. But notice there's already a -3 in front, so I'm going to be multiplying those 2's by that -3 that's already out front. And then I have this 2 that couldn't come out. It's going to stay underneath. So 2 times 2 is 4, and 4 times -3 is -12 square roots of 2. So this is our second piece. So now I've simplified each one individually, and now I look at them and they are like terms because they both have the square root of 2. So now I can go ahead and subtract 10 minus 12, which is -2, and then just put it with that radical that's the same on both of them. So -2 square roots of 2. All right, let's try another one. If I can get it to come up. There we go. So 3 times the square root of 27 plus 5 times the square root of 48. So again, I'm going to simplify each one separately, and then I can see if they can be combined. 9 is 3 times 3. So this is a square root, so for 2 the same, I can bring 1 out. So I can bring a 3 out front there's already a 3 out front, so it's going to get multiplied by the one that's already out there, and then that one has to stay inside. So this one simplifies to 9 times the square root of 3. So now we're going to simplify this second radical. So 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So again, a square root, I need 2 copies. So I have 2 2's. I have 2 2's. And then that 5 is already in front, so I also need to multiply it by that 5. And then I will be leaving that 3 inside. So 2 times 2 is 4, and 4 times 5 is 20. So this is going to become plus 20 square roots of 3. So now that they both have the same root with the same number underneath the radical, now I can add those numbers out front. 9 plus 20 is 29 times the square root of 3. Okay. All right, let's go ahead and try more. Just keep going. So on this one, I have 3 square roots of 24 plus 7 roots of 54. So again, they don't match. This one is also a square root. If I had a cube root or a fourth root, remember, they would both have to be the same, and then I would look for a different number of copies underneath, right? On a square root, I look for 2. On a cube root, I look for 3, and etc. So 24 is 8 times 3, and then 8 is 2 times 4, and 4 is 2 times 2. So I do have 2 2's underneath, so when I can bring one out and times it by the 3 that's out front, and then I have a 2 and a 3 that are going to stay inside. So if I multiply those back together, I get 6. So that simplifies to 6 roots of 6. 54 is 2 times 27, and 27 is 3 times 9, and 9 is 3 times 3. So for these 2 3's, I can bring one out. There's already a 7 out front, so I need to multiply that 7 times that 3 that comes out to get 21, and then the 2 and 3 need to stay. So again, now they match. I can go ahead and combine them. 6 plus 21 equals 27 square roots of 6. Okay. All right, so just the same process. Again, we have square roots, so we're looking for copies of 2. So 18 is 2 times 9. 9 is 3 times 3. Since I have 2 3's, I can bring one out front. There's nothing out front this time, so I just pull the 3 out, and then I leave a 2 underneath. 32 is 16 and 2. 16 is 4 and 4, and each of those are 2 times 2. So on this one, I can bring out a 2 for that one. There's already a 7 here, so I'm going to multiply it by the 7. There's a 2, another 2 I can bring out there, and that one stays underneath. So 7 times 2 is 14, and 14 times 2 is 28. So it's 3 square roots of 2 plus 28 square roots of 2 equals 31 square roots of 2. All right. Now we have a 4th root here. So because they're both 4th roots, I can combine them, but only if they simplify to the same number underneath the radical. So 162 would break down to 2 times 81. 81 is 9 times 9, and each of those break down to 3 times 3. So because it's a 4th root, I need 4 copies of the same in order to bring one out. So because I have 4 3's, I can bring that 3 out. Notice there's already a -1 out here. If I don't see a number there, it would be a -1. So that becomes a -3, and the 2 would have to stay underneath. It's still a 4th root, right? 32 is 2 times 16, and 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I have 1, 2, 3, 4 2's that I can bring out. So 1, 2 comes out for the 4, right? And then I multiply it by the 5 that's already there. So this is going to be plus 10 4th roots of, and I just have that 1, 2 left underneath. So now they're like terms because they are both 4th root of 2. So now I can combine those numbers out front. -3 plus 10 is 7 4th roots of 2. All right, so now notice this times in here. We're going to be multiplying these together instead of adding or subtracting them. So when you multiply radicals together, you're going to take any number out front and you're going to multiply it by any other number out front. So in this case, 2 times 3 is 6. Then you're going to look at your radical. I'm going to be multiplying the radicals together. I have to first make sure they're both the same root, and these are both square roots, so it's fine. And then under the radical, I'm going to be multiplying 20 times 2. So I can only multiply numbers that are outside the radical with other numbers that are outside the radical. And I can only multiply numbers that are inside the radical with other numbers that are inside the radical. So this would become 6 times the square root of 40. Now, that is the answer, but it's not fully simplified, so I would need to go ahead and simplify it. So 40 is 4 times 10, 4 is 2 times 2, and 10 is 2 times 5. So this was a square root, so I'm looking for 2 copies in order to bring one out. So I can bring a 2 out. It's going to multiply by the 6 out front. The 2 and 5 will have to stay inside because they don't have pairs. So 2 times 5 is 10. So this would simplify to 12 square roots of 10, just multiplying the 2 and 6 back together. So again, if you're multiplying, you multiply outside numbers by outside numbers, and you multiply radical under the radical numbers by under the radical numbers. So let's try one more. So here I don't see a number in front of the radical. Remember, if you don't see a number there, it's going to be a 1, or 1 times this number. So the outside numbers are just 1 and 6. So 1 times 6 is 6. And then underneath the radical, I have the 5 times 4, which is 20. Okay, so only multiply outside numbers by outside numbers, inside numbers by inside numbers. All right, so notice here I have some parentheses. I've got 2 square roots of 5 outside. I've got 2 plus 5 square roots of 4 on the inside. So before we do this problem, let's think about if I had something like 2 times x plus 5, right? What I need to do with this number that's outside is I need to distribute it in to these numbers that are inside the parentheses. Everything inside gets multiplied by 2. So this would be 2x plus 10, right? So we're going to apply that same way of thinking, but we're doing it now with 2 square roots of 5 is our outside number, and then 2 plus 5 roots of 4. So this I'm going to think of as one term, and I'm multiplying that term by 2 first. Then I'm going to multiply that term by 5 times the square root of 4. So let's do 2 first. 2 has no radical with it. So I'm only going to be multiplying that number by the number that's outside our radical. So 2 times 2 is 4. And then it's still multiplied by the square root of 5. It's just that there's no square root here to multiply that number by anything. So it's going to stay as a 5. So this would be 4 roots of 5. Next, I'm multiplying 2 roots of 5 times 5 roots of 4. So that one does have a number outside on both of them. So I will be adding on 2 times 5, which is 10, so outside number times outside number. And then under the radical, I'm going to be multiplying inside number by inside number. So 5 times 4 is 20. Now 20 breaks down to 5 times 4, we just saw that, right? And then 4 is 2 times 2. So because this is a square root and it has 2 2's underneath, I can bring that 2 out front and multiply it by the 10. So this would be 4 square roots of 5 plus 20 square roots of 5, right? 5 is left underneath there. So this would go, or this would simplify to 24 square roots of 5. So once we simplified that, we saw that they both have square root of 5 as the radical, so we can go ahead and add them together. So let's try one more of those. So I've got negative 3 square roots of 15 times the square root of 10 plus 5 times the square root of 4. So again, think of this is all one term here, negative 3 roots of 5. I'm first going to multiply it by square root of 10, then I'm going to multiply it by 5 square roots of 4. So when I multiply it by square root of 10, there's no number in front, which means it would just be a 1, right? So this is negative 3 times 1 on the outside. And on the inside, I've got 15 times 10, or 150. So that's the first term multiplied by square root of 10. Now I'm going to multiply that negative 3 square roots of 15 times 5 square roots of 4. I'm going to multiply the outside number by the outside number, so negative 3 times 15 would be, or 5 would be negative 15. And then here I have a plus minus in between, which means it's going to become a minus. And then underneath the radical, I've got 15 times 4. So 15 times 4 would be 60. Now I can go ahead and reduce this and see if anything, or if I can combine them, if anything can be more simplified. So 150 would be 15 times 10. 15 is 3 times 5, so those are both prime. 10 is 2 times 5, and this is a square root, so it looks like I can bring a 5 out front. There's already a negative 3, so out front I'm going to have negative 3 times 5, which is negative 15. And then on the inside, I've still got a 3 times a 2 that can't come out, so that'd be 6. Now the second one, 60, as we just saw, is 4 times 15. 15 is 3 times 5. And 4 is 2 times 2. So there are two 2's underneath, so I can bring a 2 out front and multiply it by this negative 15, so that's going to become negative 30. But underneath is left 15. So they're both fully reduced as much as possible, but they're not like terms, so I'm going to have to leave my answer like that. I can't go ahead and combine them because the numbers under the radicals are different. So just that would be my answer, and I would leave it like that. All right, so we're going to shift gears just a little bit, and now we're going to simplify this expression. So the way we're going to do this is we're going to remember on the last few assignments when we changed forms from radical to exponential and exponential to radical and vice versa. So what we want to do here is we want to actually go ahead and simplify this as much as possible. So remember, if I have a rational exponent, meaning like a fractional exponent, then I'm raising this to the third power, and then I'm also taking the square root of it. So to remind myself of that, I'm going to put this in radical form. So in radical form, 49v squared goes underneath the radical. The 2 underneath tells me this is a square root, so I don't have to write a 2 here, but I can. But if I don't write it, it's still a square root, right? If there's no number right there. And then it's going to all be raised to the third power. Now I'm actually going to go ahead and simplify this. I could raise it to the third power first and then take the square root, but that's going to give me some pretty large numbers that I don't want to have to work with. So instead, I'm going to take the square root of this stuff first, and then after I take the square root of it, then I'm going to raise it to the third power. So I'm only looking at this part in here for now. I'm going to kind of ignore the third power until the end. So I want to simplify 49v squared. It's a square root, so I am looking for, copies of 2. 49 is 7 times 7, and v squared is v times v, right? So we've got 2 v's and 2 7s, so 7v is going to come out of there. Because there's nothing left inside, the square root part is just going to go away because no numbers are left. And then I've got to remember that this whole thing should be raised to the third power. So 7 to the third times v to the third is going to be my answer. I can go ahead and multiply 7 to the third out. That's just 7 times 7 times 7, right? And 7 times 7 is 49. And 49 times 7 is, do it the good old-fashioned way, 7 times 4 is 28, so that would be 343. So this would be equal to 343v cubed. Okay, so just go ahead and do the root first. So, well, I guess we should say first we're going to put it in radical form. Second, we're going to take the root, apply the root, simplify it, and the third one is to raise it to the power. And that way we can get it all simplified. So let's try another one. 36n squared all raised to the 1/2 power. So first step, put it in radical form. So 36n squared goes under the radical. This is a square root, and it's raised to the first power. So both of those, I don't actually have to write, right? On this one, all I'm doing is taking the square root of 36n squared. Well, I know that the square root of 36 is 6 because that's a perfect square. And I know that the square root of n squared is n because n squared is a perfect square. It's n times n. And nothing would be left underneath, so this would just be equal to 6n. So one last one here. I have x to the 16th and raised to the 5/4 power. I'm going to change forms. So this is x to the 16th underneath the radical. I'm taking the 4th root, and then I'm raising it all to the 5th power. So again, I'm going to take the root first, so I'm going to ignore the 5th power, and I'm just going to simplify what's in here. If I have 16 x's multiplied together under here, and I need 4 the same in order to bring one out, that means I'm going to be able to bring out 4 x's, x to the 4th, right? For every 4, I can bring 1 out, and there's 16 of them, which means I'll be able to bring out 4, and nothing will be left underneath. Then I can raise this to the 5th power. And remember, if I have an exponent raised to another exponent, I can just go ahead and multiply those together. So this would be x to the 20th power. Now, another way to do it is just remember that if I have x raised to the 16th power and then I raise it to another power like 5/4, I can just go ahead and multiply those together. So that would be x to the 16 times 5/4 power. And then 4 goes into 16 4 times. So either way, it's x to the 20th power. Okay. So good luck with this, guys, and I hope that you can get that assignment done. There are a few at the bottom that you don't need to worry about for today. We will talk about those later. So have a great day. Bye.